PiHole is a piece of free open source software that basically acts as a DNS server, and you set it up on a device on your home network, and then you route your DNS queries through that device. And effectively what it does is it blocks ads and malicious URLs from being accessed by any device on your network without having to manually install software and do things to each individual device. So we're going to be using the Raspberry Pi 3 Model B Plus. For those who don't know, Raspberry Pi is basically a full-blown computer on a single little printed circuit board here. It does run ARM processor cores, so you can't install your normal x86 version of Windows or anything on it, but there are ARM versions of various operating systems, including Linux. There's Windows 10 for ARM and various other things. We're going to be using for this project Ubuntu Server 18.04, the ARM release. Not Ubuntu Core, but there has actually been a port of regular old Ubuntu Server 18.04 for the Raspberry Pi. So this is the Raspberry Pi 3B Plus. You can see we've got a regular Ethernet, 4 USB ports. We've got GPIO pins, which we're not going to use, but if you wanted to use a Raspberry Pi for other things like controlling robots or turning lights on and off or driving a display or all kinds of stuff, that's what you would use. On this side it has a 3.5mm audio out. It has an HDMI out. That's a full-size HDMI. It's not micro or mini HDMI or anything weird. On the underside it has a little micro SD card slot where we're going to actually install a micro SD card to hold the operating system. The one strange thing about the Raspberry Pi is that it doesn't have a normal boot up process, so you can't just take a normal Linux installer image and say boot from USB and install it that way. You have to have sort of pre-installed images of the operating system that you wish to use and then flash that image to the micro SD card with something like Etcher, and then the Raspberry Pi will boot directly off of that. Now, I purchased my Raspberry Pi as part of a kit. It came with the Raspberry Pi itself. It came with a power cord that has a toggle switch in it. The Raspberry Pi just runs off of micro USB, and so it came with a micro USB power cord that plugs directly into an American wall outlet. That just happens to have a little toggle switch in the middle here, so you can flip the Raspberry Pi on and off, because it doesn't have any sort of ACPI on and off function. So even if you were running Linux and you told it to shut down -H, it'll shut down the operating system, but it won't actually power off the Raspberry Pi. So this gives you a hardware way to turn the device completely off and back on. And the other thing it came with is this case. Now this case is interesting. I've actually built one other Raspberry Pi with this case, is the reason I ordered it. And with this case, the case is the heatsink for the device. So the case is made of aluminum, and you can see it's got these little studs at various points inside of it, and what they do is they will actually contact the CPU and things and transfer heat from those devices to the case itself. You can see there's a little bump here that presses up against the bottom side of one of the chips, and so what this means is that the case for this Raspberry Pi might get a little bit warm, but the entire case is the heatsink, so I don't have to worry about having a plastic case with little heat sinks inside there that aren't necessarily getting amazing airflow. The case itself is the heatsink, so if you think your Raspberry Pi is getting a little bit hot, just cool the case itself. You know, put it in a place where there's good airflow, and the case is the heatsink. So let's go ahead and start assembling this thing. You can see here that in this little plastic baggie we've got some rubber feet and some screws for it. It came with an Allen wrench. It came with a little spreader to help you spread the thermal paste around. It did come with thermal paste. It came with a little instruction manual. We're not going to need all of the thermal paste that's in this, so if you want, you can actually keep this thermal paste around and use it for your PC or other things that you might need a little extra. Alright, now you can see that on these ends of the case there's actually cutouts. What those are for actually is for the Raspberry Pi to sort of sit in here, and these little studs go down in between the USB ports, kind of act like a brace, and it sits in there like that. And then the other half has a similar cutout, so it'll just kind of go like that-ish. And so what we need to do is we need to go ahead and apply our thermal paste to the 1, 2, 3 spots that are going to be contacted by these studs on the case itself. Okay, set that off to the side. And now this side goes into this half with the cutouts lined up with the end that has the I/O. Okay. And there's going to be just like that. And you'll know you've got it right because your HDMI port and 3.5mm will be there. So then we take this half of the case, I/O end, and we just ease it down over top of it, keep it straight as we can. Once it's straight and lined up, just kind of press it together. Pick it up as a unit, keep it squeezed together. You're going to have a hole here. This slot is for accessing the GPIO if you want to use it. You're going to have a hole here for accessing the micro SD. There's another hole here for running wires if you need to. Micro USB, HDMI, 3.5mm, and your other normal I/O. So we're going to flip it upside down, place it on the table upside down like that. So now we're going to take our little baggie with the feet and screws. We're going to open that and pour them out on the table. Okay, now we're going to take our little feet. I'm going to peel those off. So it is assembled. So the next order of business is actually to flash the operating system of choice to our micro SD card. I have here a Samsung Evo Pro 32GB micro SD card. This is actually kind of overkill for what I'm doing with this, but it's the one that I've got on hand, and worst case scenario, I can always repurpose this micro SD card later. You're also going to need a PC and some sort of adapter to read this and actually write data to it on your PC. Now, there's two versions of this Raspberry Pi kit. I bought the cheaper one this time around that just comes with the case and the power cord and the thermal paste and things. There's another version of this same kit with the same hardware that actually also includes an HDMI cable, a micro SD card, and this little thing for writing data to the micro SD card. It looks like a little thumb drive, but if you look at the end of it here, it actually has a little female slot up here where you can take a micro SD card and slide it in right there, and then just plug it into a regular USB port on your PC to write data to this. Now the next order of business is to download the operating system software that we want to use and then flash it to that micro SD card. If you go to raspberrypi.org, which is the official Raspberry Pi website, and hit downloads, it'll actually take you to this page where you can download either Raspbian, which is their official flavor of Debian Linux made for the Raspberry Pi, or you can download Noobs. Now, Noobs is not an operating system in and of itself. Noobs is a piece of software that the Raspberry Pi will boot, and then it gives you a menu with a selection of different operating systems, including Ubuntu, Snappy, Core, Windows 10, IoT Core, Raspbian, and a few other things. And what it does is when you make a selection from that menu, it downloads that software, flashes it to the micro SD card, erases itself, and it sets it up for you. It makes it a little bit simpler. Now, if you go to the Ubuntu website and you go to Downloads and click on Raspberry Pi, it actually takes you to Ubuntu Core. That's not what we want to do. If you do a search for like Raspberry Pi Ubuntu server download, you'll find this wiki page here. wiki.ubuntu.com/arm/Raspberry Pi. And you've got a couple of things listed here. The Ubuntu Core, obviously. But then you have Ubuntu Classic, which, from my understanding, was actually just recently ported to the Raspberry Pi. And we've got a few different images here. So I've already downloaded the ARM64 image for the Raspberry Pi 3B and 3B Plus. So we're going to use a piece of software called Etcher to write that to our micro SD card.
Now I've got Etcher pulled up here. Etcher is available for Windows. You don't have to be using Linux to run it. So we're going to go here. We're going to hit Select Image. Go to Downloads. Scroll down. And right here. Now when you first download the image from Ubuntu, it's going to come in this .xz archive format. You may need to use something like 7-zip to extract it if you're on Windows, but you're going to need to extract this .img file out of this archive. So we've got Ubuntu 18.04.2 pre-installed server ARM64 Raspberry 3.img. So we're going to hit open. It has already detected our 32 gigabyte micro SD card. We hit flash, and it's going to flash that operating system image to the micro SD card.
Alright, so our micro SD card has finished flashing, so we're going to go ahead and remove that from the little adapter here. We're going to flip it over. We're going to install it gold pin side toward the Raspberry Pi, like this, into its little slot, and it's installed. It's going to remain exposed like this, but there the Raspberry Pi is physically complete, so we need to open up our power cord here and get it connected to a display. And the first time you boot these operating systems that are made for the Raspberry Pi, including Ubuntu server, they will actually grow their primary partition to fill the free space on the device. So even though if you look at the micro SD card immediately after flashing it, there's probably going to be a lot of free space. Once you boot the system, it actually stretches and fills that free space up. So don't worry about that. So we got our power cord. Let me dig out the HDMI cable and get it connected to a display.
So as you can see here, we've got the Raspberry Pi connected to power, HDMI, Ethernet, and we've got a wireless keyboard and mouse hooked up. So let's go ahead and get this thing started.
So hopefully the camera does not have a brain fart trying to stay focused on this display in the dark here. But I was getting a lot of reflection with the lights turned on. So when we power on the Raspberry Pi for the first time, two things are going to be true. Number one, it's going to take a little bit longer than usual to boot the first time you ever start it up. And number two is we should see a square with a rainbow gradient to it. If you have your micro SD card installed and you power on your Raspberry Pi and you don't get that square with the rainbow gradient, that means that whatever image you flashed to the, that micro SD card is not something that the Raspberry Pi can boot. So make sure that you have good power and that the little power LEDs are on and that the micro SD card is installed properly. But if you don't get that little rainbow square, it can't boot whatever it is that you put on the SD card. Out of focus here. There it goes. Now, when it pops, if it shows this stuff after it says Ubuntu login, that's fine. Just go ahead and press enter so you get another login thing here. By default, username is Ubuntu. Password is Ubuntu. The first time you log in, it's going to ask you to change that password. So our current one is Ubuntu. Our new one is going to be this. Alright, so we're in a terminal now. So our next step is going to be to make sure that we are configured for the correct time zone. We're going to do sudo space dpkg dash reconfigure space tz data. It's going to ask us what region we're in, so we're going to select US. We're going to select Eastern Time Zone since that's where we are. Current time is 23:28. That's correct. Alright. The next thing we're going to do is we're going to actually update the Ubuntu operating system software itself. So we're going to do a sudo space apt space update. And all that does is it updates the list of available packages and versions that are in the repositories. It doesn't actually install anything on the system. Alright, 44 packages can be upgraded. So we're going to do sudo space apt space upgrade. We're going to say yes. And this could take a little while. Alright, now we're going to do a sudo space apt space dist dash upgrade to grab any other packages that weren't already updated with that. Alright, we're good there. So now we're going to change the host name. This step is optional, but I want the host name to be something other than just straight normal Ubuntu. So we're going to do sudo space nano space /etc /hostname. We're going to delete the word Ubuntu and we're going to name it PiHole. We're going to hold down the control key and press O. Say enter because yes, we want to write it out to that file. Then we're going to say control, then we're going to hold the control key and press X. Next file we're going to edit is sudo space nano space /etc /hosts. And we're going, if there's already a line here that has Ubuntu listed, we're just going to edit the word Ubuntu there. If there's not, then what we're going to do, we're going to enter down one line below localhost, and we're going to enter the IP of 127.0.1.1 space, and we're going to put our desired host name of PiHole. We're going to hold control and press O, press enter, then hold control and press X. And now we're going to reboot. So we do sudo space shutdown space -R space now. Alright, so we're at our login prompt here. Our username is still just Ubuntu, but the new password we set earlier. Now we're actually going to install the PiHole software. So we're going to do sudo space curl space minus lowercase s, uppercase S, uppercase L, space https:// install.pi-hole.net space pipe bash. Now, there are alternative methods of installing PiHole if you don't want to just pipe something into bash. They have alternative methods listed on their website, like cloning a Git repository, but this method is perfectly adequate for our purposes. So we're going to say enter. The installer will transform your device into a network-wide ad blocker. Okay. PiHole is free, powered by your donations. PiHole is a server, so it needs a static IP address to function properly. Okay. Now these are DNS providers. What these are for is your DNS queries are all going to go to your PiHole. Anything that the PiHole deems appropriate that it allows through is going to get forwarded to whatever service you select here. So we're going to select OpenDNS. These are the lists that determine what gets blocked. We're just going to leave them all checked, hit tab down to OK and hit enter. IPv4 and 6 both, tab down, OK. Do you want your current network settings as a static IP address? So you may also need to go into your router and reserve this IP address, but what this does is it assigns whatever IP it has now as a static IP locally on this machine. So we're going to say yes. And this basically just tells you what I just told you, but you might have to reserve that IP address in your router's configuration. Do you want to install the web admin interface? Yes. Do you want to install the web server? Yes, you have to have that to use the web admin interface. Do you want to log queries? Yes. Show everything. And now it's going to install PiHole with the configurations that we gave it. Now when it finishes and it gets to this point, what you want to make note of is both the IP address and your admin web page login password is. You want to write this down because this is going to be how you log in to the web admin web page that's being hosted by the PiHole, so that you can manage it and see what's going on. So let's go ahead and hit OK. So the last thing I'm going to show you with this is, let's say that you want to, at a later date, update your PiHole software, or just make sure that it is up to date. You're going to run sudo space PiHole space -up. So everything's up to date. Now that is everything that we need to do on the device itself. It has SSH pre-configured on the machine so that we can log into it remotely over the network if we want to. You can now shut this down, stick it to the top of your router with nothing but its power cord and an Ethernet cable, and just leave it alone and turn it on and just let it run. So to shut it down properly, what we're going to do is we're going to say sudo space shutdown space -h lowercase space now. Now in a normal Linux PC, this would actually shut the computer off. On the Pi, obviously it has no ACPI power function, so after it's done shutting down and you lose video signal, you have to manually click your little power switch to power off the device. And then you can take it and put it wherever it is you want to store it and hardwire it to your router.
Now the next order of business is actually going to be to configure your router to use the PiHole as its DNS server. So you're going to want to go to the IP address of your router in your web browser and then log in. I'm actually using a Linksys router, so most Linksys routers should look similar to the way mine does. If yours looks different, you'll need to research how to set a custom DNS server in your router. So what we're going to do on my Linksys is we're going to go to Connectivity. We're going to go to Local Network, and Static DNS1 is set to the IP address of my actual PiHole. Now this isn't the IP of the PiHole we just made. For the rest of this video, we're going to be using my actual running PiHole as examples for how to set this up. So static DNS1 is the IP address of my PiHole. No other DNS servers are entered, because what will happen is if you set Google or OpenDNS servers to these other slots, then when, say, an ad tries to load and your PiHole, which is static DNS1, blocks it and it fails to resolve, your router is just going to go on down the line to OpenDNS or Google and resolve that IP and load the advertisement anyway. So your PiHole needs to be your only DNS server, and then your PiHole will route anything that it allows through OpenDNS or Google or whatever it is that you want to use. So after you've got your PiHole IP address punched into static DNS1 and nothing in the other slots, you're just going to go ahead and hit OK and perhaps reboot your router if you want to, and that part is done. Now at this point the PiHole is functional. Your internet traffic is being routed through it and filtered. There is nothing else after this point in this video that is required for the PiHole to actually be functional. So if you don't care about monitoring what is being blocked and what is being allowed and things of that nature, and you just want it to work, you're done at this point in the video. The next thing you want to do is go to your web browser and type in the IP address of your PiHole /admin, and you'll actually be landed at this dashboard page. You're going to go ahead and click the login link, and you're going to enter the password that the PiHole gave you when it finished setting itself up. If you want, you can hit remember me for 7 days, log in, and then it'll actually give you a lot more useful information. It'll give you a breakdown of how things were blocked, what types of queries were blocked. It'll tell you what clients it's been blocking traffic for. You can go down to query log and you can see individual addresses that have been accessed or blocked and the devices that we're trying to connect to them. You can manually whitelist or blacklist addresses found here, or you can click whitelist or blacklist and manually add things here. Now I still had to do some configuration tweaking to get things working the way I like them. For example, at this point the PiHole was functioning properly, but everything on the query log looked like it was coming directly from the router. I didn't have individual clients listed under the client tab, and there's no option in the user interface for my Linksys router to disable that sort of built-in DNS service that was causing everything to look like it was coming from the router. So in order to get individual clients to be listed separately on the query log, I actually had to go into each individual device on my network that I wanted to appear individually and configure the DNS servers to be static. Now Windows and Linux PCs can be configured this way. I was able to configure the Nintendo Switch to have static DNS only. Our Android cell phones, I had to assign everything statically because they didn't have an option for only the DNS servers to be assigned statically. So you can see here in my connection properties in Ubuntu under IPv4, IP address, subnet mask, and gateway are still set to automatic, but DNS is set to manual and pointed directly at my PiHole. Like I said, you can do this same thing in Windows where you only assign the DNS server static and everything else is still dynamic. Now after doing that, I had the individual clients showing up under the client column here so I could see which devices were accessing which addresses, but it was just listing their IP address. In order to get hostname resolution, there's a couple of things that need to be done. First, in the PiHole admin page, we need to go to Settings, DNS, scroll all the way down to the bottom, and check Use Conditional Forwarding, and then punch in the IP address of your router and the local domain name, which is the host name of your router. Now in a Linksys router, the host name is right up here at the top. You can see mine's Adams-router. Alright. The other thing I needed to do is I needed to go into Connectivity, Local Network, DHCP reservations, and I set up reserved DHCP addresses for most of my devices with a host name that I wanted them to appear as in the PiHole query page, because whatever host name you set here is what's going to show up in the PiHole query page. Now this host name doesn't have to actually match what is configured as the host name on that device. For example, our Nintendo Switches are not named, Alistair-Nintendo Switch. It's some off-the-wall default host name that Nintendo gives to the device that you can't change. But the Nintendo Switches actually show up using these host names that I set when I created DHCP reservations. After creating DHCP reservations with host names that I like and setting up conditional forwarding in the PiHole itself, when I go to query log now, my actual individual devices have the host names that I have configured listed under the client column. So now it's really easy to tell which devices are connecting to which addresses. And that is the PiHole software. Remember, it is also available on x86, so if you already have a home server that's running Linux, you can go ahead and install PiHole in the exact same way that we just installed it on the Raspberry Pi here. Mine's actually running on my home server that's got like a 6-core Phenom 2 processor in it, and it works just fine. Don't forget to log in every once in a while and install updates both to the underlying operating system and to the PiHole software, either directly with a monitor and a keyboard and mouse or over SSH. If you guys have any comments, questions, concerns, or suggestions, please feel free to leave them in the comments section below. If you're having trouble with something that I covered in this video, please feel free to comment or direct message me, and I'll try to help you out to the best of my ability or point you to resources to help you fix whatever problem you're having. As always, this is Marcus out. Y'all have a good one.